good afternoon. My name is Uk Son. I'm an Associate Dean for the Office of Development Research and International Cooperation of the KDIS School, and also one of the organizers of this conference. I'm happy to play a moderating role for session 1 of this conference. The theme of this session focuses on the human capital development under COVID-19. Okay. So the first paper is what works to control COVID-19, Econometric analysis of the cross-country panel. So the ADBI economist, Rana Hassan, please.
Dr. Son, thank you very much. And colleagues, thank you for allowing us to participate and also present this work. This work, as you can see from this first slide, is joint work with Li-Ming Chen, David Reitzer, Rose Lavado, and Orly Velarde. Orly, please, next slide. So essentially the motivation, let me quickly go over the motivation. As everyone knows, we've seen governments everywhere using a variety of non-pharmaceutical interventions to control the spread of COVID-19. And some of these measures seem to have been more costly from an economic sense. Others have been less costly. But nevertheless, we see COVID cases continuing to rise. The fact that we've seen many different measures being implemented raises a number of questions. And the first one is, of course, how effective are these various measures? And finally, does the intervention effectiveness vary depending on context? And we also look at this issue of how costly these might be. Next slide, please, Orly. So in terms of our main dependent variable, this is basically the country level reproductive rates. And we decided to use this variable because in a scenario where you have lots of data problems with cases or mortality, these effective reproductive rates tend to reduce some of these measurement errors to some extent. So for each country, we have these reproductive rates over time. And over here in this chart, basically, we've shown you how the average developed economy RT has behaved versus the average developed economy RT rates. Next slide, please. In terms of the explanatory variables, we basically look at a set
Rana, I'm here.
Okay, David, go ahead. So Dr. Son, if you don't mind, my colleague David is now going to take over.
Okay, no problem.
Okay, sorry, I had some technical problems getting in. Do I have control of the presentation now? Yes, okay. So within this regression, what we use as explanatory variables are variables that relate to policy measures that we seek to consider. These are daily variables on lockdown type measures such as school closure, workplace closure, public transport closure, gathering bans for different sizes, and Google mobility to capture overall changes in people's time at home versus going out. We also have contextual or other non-NPI types of measures such as contact tracing, the use of early contact tracing, a large-scale testing, whether it's present, whether masks are mandated, and whether there's a paid sick leave policy. Now, the last variable is something that we will bring in. It's a time invariant variable, but we bring it in as affecting one of the other measures later, as I'll explain. In terms of the variables that we use, these are for 75 countries where we have data available from these various sources. These are daily observations, so it becomes 6,600 observations. The data look a bit like this. There's not a lot of time to go into the details. Beyond those kinds of policy measures, we have these contextual variables, and the contextual variables include the maximum temperature, household size, an overall control for time trend to absorb general trends over time, counting from the first day of cases in the country. And then something else, which is about the presence of new strains, new mutations of COVID-19 in the particular country at the time. The approach that we use is a two-way fixed effects regression. The idea is the same as difference in differences. It gives causal estimates conditional on the parallel trends assumption that absent the measures being taken, the trends would be similar. And the focus is really on changes, not on states. So it's the change in the effective reproductive rate against the change in the policy implementation variables. I'm sorry, go back. It went ahead one slide. Okay. It drops out time invariant sources of selection bias. Any time invariant variables do fall out except in terms of time variant effects. And by focusing on daily changes, we're able to avoid problems of multi-collinearity, because you could imagine that a lot of the policy measures are adopted by the same countries, but they aren't adopted by the same countries and exactly the same time. And we also use a second approach, which is a generalized unconditional quantile fixed effects regression, which is similar conceptually to the two-way fixed effects regression, but allows us to do estimates not just at the mean, but at different points in the distribution. So we can see heterogeneity in terms of the effects of the measures. The empirical specification looks like this. We do some smoothing on the right-hand side of taking 3-day moving averages up to the point of the effective reproductive rate. And we also do include day of week controls, because there's some day of week effect in terms of reporting and in terms of the effects of some of the policy measures. Now on this question of whether the variables are really independent, when one looks at these daily variables that we've been using, surprisingly at the daily level, 3-day moving average, there's not a lot of correlation among each of the variables when one looks at whether they're changing. In overall states, there would be many countries would be using many of the measures simultaneously in the end, but when they start the different measures seems to be different, so that they're not perfectly correlated. And so that allows us to identify independently the effects of each. So the baseline results look like this. We first start with a very simple regression that is a regression of the effects of the measures, effects of mobility alone. We find a highly significant effect of people staying home more, which is to be expected. If we compare that to looking at the effects of the policies themselves, the basic policies, we find a lot more explanatory power, however. And we find that a lot of the effects come from gathering bans, from school closure, workplace closure, et cetera. Other measures also have effects: mass testing, contact tracing, doing contact tracing early. We find we further enhance the explanatory power if we use both. If we put the staying at home together with the other policy measures, the significance is still maintained for the other policy measures, but staying at home more seems to bring in something additional. So people respond not just to these specific policy measures, but to other signals and other measures, and that affects the reproductive rate. And then if you look at the right-hand column, we bring in this paid sick leave interaction with contact tracing, and we find a very highly significant interaction, a very substantial coefficient that basically paid sick leave enables contact tracing to work. And in the absence of having paid sick leave, contact tracing is not effective and becomes actually insignificant. So we think we found something quite interesting there. In addition to those major measures, there are also smaller effects of mask use and mass testing. The individual policy measures in terms of school and workplace closure also become quite a bit smaller. But we think we have a nice model there with a sensible story and whatnot. If we add in, then we look at mutations. I don't know if what people have heard in the media about new mutations increasing infectiousness. We do find some evidence of this. So we put in the presence of different strains. We find one of the newer strains is increasing infectiousness. We don't use this for our main regression because it reduces the number of countries, but it does enhance some of the other effects that we find. If we compare developed and developing countries, we also find some very interesting differences. We find the effect of staying home more is much more pronounced in developed countries. You can't see it here, but it's very highly significant. In developing countries, it's not so significant. We find larger effects, however, interestingly, of the interaction of paid sick leave with contact tracing and mass testing in developing countries, which might be a little bit counterintuitive, but this is what we find. We also find that school closure has a bigger effect in developing countries. We also look at the effects at different points in the distribution in terms of the effective reproductive rate. And we find also interesting differences. Staying home has much higher effects. The higher reproductive rate, school closure has larger effects and lower reproductive rates. The tracing by paid sick leave has a higher effect and higher reproductive rates when there's a worse epidemic occurring. So all the measures are not equally effective in different contexts and different stages of the epidemic. We also do a simulation exercise of what would have happened if the measures were not taken. So if the adopted measures were not adopted. And we also find some similar patterns as you might expect. Staying home had a substantial effect. The reproductive rate would have been much larger. Not having contact tracing in the context of paid sick leave, there would have been a much larger reproductive rate. The sample of countries differs a little bit here, so that's why some of these rates are a little different without the measures. In terms of the gathering bands, they make a little bit smaller contributions. The school closure makes a bit smaller contribution where it's been undertaken, and the other measures make a little bit smaller differences if they had not been done. But the cumulative effect of all of them could be important. So, do these patterns, are they consistent with what's been found in other literature? For the most part, a lot of the big storyline is consistent in terms of the effects of lockdown, that there are effects of school closure, there are effects of mobility reductions. What we find compared to previous literature is a somewhat smaller effect of the main lockdown measures, even though they're still highly significant. The magnitude of the coefficients is smaller. But we think we have some interesting new results in terms of the heterogeneity of effects, the difference between developing and developed countries, the differences and different reproductive rates that different instruments have different effectiveness. And then this role of paid sick leave is something that we haven't seen empirically shown in the context of COVID-19. It's been shown for other kinds of diseases, and economically we think it makes a lot of sense. Because there's an externality problem in that most people have mild symptoms. So the benefit of them staying home is really to others, not to themselves. And to solve this kind of externality problem requires public sector intervention to correct the market. We also, our effect of new strains increasing infectiousness is also consistent with the epidemiological literature. So the overall messages from what we have done are that lockdowns, they're likely to be somewhat less effective. Getting people to stay home more is likely to be less effective in developing countries than developed countries. We both see that in the difference in the countries. And we also see this negative interaction effect with household size, which also would make sense when you consider that larger households have more contacts at home. So we also find that because new mutations seem to increase infectiousness, this is something that governments may need to prepare for, that the pressure of the spread of COVID-19 may be growing due to this. We find that it's really important to get contact tracing going when there's a low level of infections, and to complement it with paid sick leave to set the right incentives for the system to work. Although we find some effects of school closure, we don't find it consistently on all reproductive rates. So because it's not in all reproductive rates, we conclude it shouldn't be relied on for a prolonged period, given that it has very large costs. And we find really no significant effects of transport closure, which has been used as a control mechanism. So thank you, and sorry for joining a couple minutes late. Thank you so much.
No problem. So thank you, Rana Hassan and David Raicho.